Hey, good morning, everyone.
Morning, Professor.
Good
Hi, good
morning,
morning, Anna.
Professor.
Good morning, Jalen, and good morning, Samira. Well, I have only three people today. Louis, good morning.
Hello, good morning.
Um, Good morning. Well, it's just 2 minutes past the hour, so hopefully the rest of the class will join us shortly. Um, I just wanted to, bring to your attention that we are already into topic 4, right? By the main lecture. Okay, by the main lecture, we're already into topic 4, the bond valuation. Um, but of course, we are, collaborate session being the review and reflection. It's always, it's supposed to be behind, but you got to understand that um, the midterm is starting tomorrow, and the midterm is all about time value of money. And since everything in the time value of money is already covered by the main lecture, and we are just, collaborate session is just still in the future value of annuity. So about the present value of annuities, um, um you should have already, if you have already, follow the main lecture, you should have already, studied it already. You should have, otherwise, because they are already grayed out, you got to look up the my YouTube channel, okay, for present value of annuities before you start on the midterm, okay. Now, that being said, we're gonna uh, we're gonna continue where we have left off last time. So last time, uh, we basically found, the future value of annuities of our, example, and the example was graduate school fund, right? So you are, preparing to go to graduate school in 5 years. So you're saving $800 every month for the next 5 years, every month. So there will be 60 deposits of $800, and currently the APR is 6%, and your target future value is 60K. Are we gonna get 60K, by doing this? And we've we've uh, we tried it out, and according to our scenario, right? By our scenario of $800 deposit every month, right? We will be still, about $4,000 short, right? Uh, Second scenario, right? If we increase our deposit by $60, uh, we'll barely meet our target, right? Uh, I mean, we overshoot it just about by $2. From this, we can tell, oh, the exact monthly deposit uh, won't be that far away. It can't be that far away. It should be something slightly lower than 860. Third scenario is finding a bank that pays better interest rate, but even at 8%, we're still about, $1,300 short. Another scenario is extending our timeline to 6 years. Then, of course, we will have more than enough money by then. Uh, so our question was, is there a way we can nail the exact payment? Is there a way we can nail the exact payment? Yes, of course. Remember, uh, we solved in, a basic single cash flow model, right? Based on this base model, right? We solved that for P. We solved that for R. We solved that for N, Okay, just like that. Based on our base model of future value of annuity, which is, payment times one plus r raised to n minus 1 over r. So then think about it. This time, our unknown is this. Isn't it right? Payment is our unknown. This one is known already. Future value of annuity is known. We have already the target future value, which is 60K. R is known, right? Of course, APR, 6% APR divided by 12, we know it is 0.5%. It is known, right? And N is also known. It's 60 months, right? 5 years, right? Times 12, right? 60 months. So then, when we have, all the other variables are known. Payment is the unknown variable. And then solving for payment, I mean, this is already presenting itself in exactly the same, in the way that we want. Isn't that right? In other words, I've been telling you over and over that the key to solving any equation is identifying z equals x times y structure, right? But then here, this is already z equals x times y structure, isn't that right? Hmm?
Yes, it is.
Right, Lewis. Lewis, let's see, is it my volume or your microphone? My volume is okay. I think you might need to raise your microphone volume.
Can you hear me now?
Yeah.
Okay, cool.
It's better. It is already presented that way. So then, X is payment. Payment is X. And the thing in the bracket is Y. So basically, finding payment is, what's happening? What's going on? Okay. So the payment is FVA times divided by FVA divided by the thing in the bracket. Now you might wonder, I said divided by, but what did I do? Why am I multiplying? Well, remember, what is this? Something raised to negative power, that's reciprocal, right? -1. So think about it. Dividing by something is the same thing as multiplying by the reciprocal of that something. Isn't that right?
Yes.
Isn't that right? Yeah.
Yes.
So basically, if we multiply the reciprocal of the thing in the bracket, that's basically dividing, right? So then if I rewrite it, that's going to be FVA times the reciprocal is going to be r times 1 plus r raised to n over 1 plus r raised to n minus 1. Okay? Check the formula here. This is, if you flip it, it becomes this, right? It becomes this. So we got our formula for payment. So let's go to, and I also put that formula here, somewhere here, yeah. And I also explained it here. Let me move that up. Okay. So using that formula, we'll find, okay, first, we'll have to get this filled in. Of course, we know what it is. We'll just copy. And it's basically the formula that gets copied, right? Yeah, we know how to find periodic rate and how to find, n, the actual compounding, actual number of compounding. So all we need to do is then FVA times, oh, what did I do? Here, start with the equal sign. FVA times R times 1 plus R to N. Well, I want you to do this with me now. Don't just watch. Don't just, watch it, but you need to, I understand, you can't do it at the same time because while you're watching this, you cannot open the, even if you have Excel open, you can't have, unless you have, probably if you have two monitors. I don't have two monitors. I just have, my laptop. I cannot see both. But anyway, then divided by 1 plus R, 1 plus R is the N minus 1, close parenthesis, hit enter. Something's not right. What happened? What's going on? G7, FVA times R times 1 plus R raised to F7 over 1 plus E7 R raised to F7.
Professor, you have one parenthesis left to add. Or you just need, I think you have to put another parenthesis.
Parenthesis? No, you mean in the numerator? No, that's not necessary. I can do that, but think about it. When you multiply something to a fraction, anyway, it gets multiplied to the numerator only, numerator. So the parenthesis in the numerator is optional, or you don't, in other words, okay, let me leave it like that and, see. Oh, Jesus, I'm sorry. What did I do? I did, as if I did, it's R, okay? What did I do? I did, almost, what I did was like a, okay, sorry about that. I suddenly thought about, present value of annuity formula. Okay, so here, so the result is exactly, I told you, when we tried the second scenario, we just, barely overshot the target future value. So I said, it can't be that far away from this. Yeah, it's only about 3 cents, right? 3 cents, short of age 60. And by depositing this amount for 60 months, every month, right? Making a monthly deposit, 60 monthly deposit, will hit exactly 60K. So here, I'm sorry. I was thinking of something else. I was thinking of present value of annuity. You might have all got scared. Why suddenly out of that? Why suddenly? Where did this come from? I'm sorry. I was thinking of present value of annuity. So let me rewrite that. So basically flipping. Why in the suddenly in the numerator? So it's 1 plus r raised to n minus 1 if you flip that, right? So says just flipping. Somebody's snoring. Hello? I guess, I hear someone snore.
Yeah, I heard that too.
Or someone has a dog. Someone probably has
Yeah,
is
Professor, sorry. I didn't
little
notice I
dog,
was on
next
mute.
to him,
It was my
yeah,
dog.
next to him or her, and the dog fell asleep, uh, or cat purring, or now, yeah. I mean, think about it. You must have been puzzled. I mean, why is flipping this? It should be like this. That it cannot be like. But that was, I'm sorry. I was somewhat carried away. That was, that was the present value of annuity. That was the case of present value of annuity. But anyway, so please correct that if. So we got that. Let's try another one. This is when interest rate is 7.5, 6 years, quarterly compounding. Quarterly compounding, right? All you need to do is simply, okay, we know that divided by 4 will be the quarterly rate. And 6 times 4 will give you 24 quarters, 6 years. And all you need to do is just simply copy this, paste here. Yeah, by depositing $2,002 quarterly, right, for 6 years, in other words, 24 quarters, then you'll reach this target, right? Just now. Next question. So then, under the same scenario, right? In other words, depositing $859 every month, 97 every month for the next. So what kind of interest rate will take you to 60K? Or by making these deposits monthly, right, at 6% interest rate, how many months will it take? We already know the answer. 6% is 60 months, but how do we do that mathematically? So again, when you are given this base formula, right, from that base formula, we can also derive the formula for payment, right? Derive the formula for R, derive the formula for N. We've done this. However, unfortunately, mathematically, there is no single unique solution, single unique formula, not solution. There is no single unique formula for R in annuity. So what do we have to do? We'll have to use Excel's built-in function. Okay. For N, we have the formula, right? I'm gonna show you that formula shortly. But for the rate, what they used to do in the past was trial and error method. And the trial and error is really, literally trial and error. In other words, you try out different candidates, right? Different candidates, and plug in different numbers until you get the right number that satisfies our target. But then this is not scientific, and it's basically narrowing down the possible ranges until you nail exactly hit the nail. Then there is no guarantee that it can be done within a few tries, right? It can take so many trials and so many errors. That's why it is not scientific. But those trial and errors, computers can do that. I mean, for humans, to run like 1,000 trials, it will take huge amount of time for humans, right? But the computer can run like 1,000 trials per second. So, what computer does is not really any mathematical solution, but really the computer does this, iterative process of trial and error, right? But, that's what the computer is good for. So how do we find rate? We will have to go first, of course, we are dealing with monthly compounding, so we'll have to find the monthly rate. And you see, this is, a function icon. So if you click on function, right? And then if you have recently used this function, it will appear in the most recently used category. But if it doesn't, you go to the financial. And it's all in alphabetical order. So you scroll down until you find rate, okay? Because it's rate. We're looking for the rate. Hit OK and give it what it's asking for. N period, right? That's literally N. What else can it be? So you give it N, payment. You give it the payment. There's no present value here. It's but we have future value here. And then type. We have two more inputs. Type is either ordinary or due. Remember, annuity, ordinary annuity versus annuity due. So which type? Which type is it? Again, ordinary annuity is the default, right? By the name, it is ordinary. And in our example, it's also ordinary. Our example, it's ordinary, right? Because you're making a deposit at the end of the month. And unless otherwise instructed, right? Unless the instruction clearly specifies that this is annuity due, or you're making deposit or payment at the beginning of the period, right? Default is ordinary. And if it is ordinary, you don't put anything. You don't put anything there. Or put 0, right? 0 is blank. Nothing is. If it is annuity due, 1, you put 1. So why do you put 1? Why is it 1? To tell that it is annuity due. Now, if you remember, the annuity, when we talked about annuity, I made a distinction between ordinary annuity and annuity due, and of course the distinction is annuity, ordinary annuity is where you make the deposit or payment at the end of each period, whereas annuity due is the situation where you make that deposit or payment at the beginning of each period, But that's just verbal definition. Mathematically, how is it different? You must remember that I told you as I was doing this, right? The difference is one more compounding, right? I've been telling you the difference is one more compounding. Look, the first deposit gets compounded 4 times, second 3 times, and so on. If it is annuity due, first deposit gets compounded 5 times, second one 4 times, and so on. So every deposit gets compounded one more time, right? So what did I say? The difference between ordinary annuity and annuity due is one more compounding. So we can recycle the result of the ordinary annuity, and we simply multiply it by compounded one more time. So difference. So that's why 1, if it is annuity due, you enter 1, okay? Because that means there's one more compounding. Guess, we don't need to use guess. But here, if everything is correct, there should be something already showing here. But nothing is showing here. Why? What could be wrong? What is wrong is this one should be negative. The payment should be entered as it's not. It doesn't mean it is negative. And then voila. It doesn't mean it is negative. What that means is in financial calculator, there are 2 types of cash flows: cash inflow and cash outflow, right? And cash outflows are represented by minus sign, right? Negative. It doesn't mean really negative number. It just means cash outflow. And think about it. This is cash outflow. Think about it. Every month, this amount leaves your pocket. Isn't that right? This amount leaves your pocket, your wallet, and goes into the bank. And at the end of 60 months, right? At the end of the maturity, this 60K will come back to you. So this is cash inflow, this is cash outflow. And you need to make that distinction in the financial calculator. That's why this needs to be entered as negative. Okay? And then if you understand, then that's not the final answer. Why? If the question was asking for APR, and I told you all the interest rates are basically APR. All the rates are expressed as annual rate, annualized rate. So this must be answered as APR. And we know, oh, that's nothing, it's just simply because this is monthly rate times 12. Right? It should be then 6%. And if you got that right, just simply, try this. Copy this, paste it here. The reason it's showing nothing is because this one is missing. I'll just, drag it down. Okay. So once, this cell is done, right? Then you'll get it, right? And then, of course, that's quarterly rate. So multiplied by M, you get exactly 7.5 annual. Okay. And finally, what about the N? How do we find N? I have provided the formula for N here in the slide. It's together with the N formula for N in present value of annuity as well. So I put them side by side. So you need to find the correct one. This is for future value of annuity, right? So from this formula, base formula, going through these steps of transformation, right? Steps of transformation or derivation, you arrive at this finally. So of course you have to use natural log, right? So then this is the formula. So we'll apply the formula, right? So here, then it's the natural log of FV over payment, now times R plus 1, close parenthesis, by natural log of 1 plus R. Is the denominator is 1 plus R. Okay? Did you do that? Were you able to, okay, hit enter? Yeah, we got 60 months exactly. And then converting into years, you know, it's just that divided by 12. It's going to give you 5 years. Okay? If the problem was for how many years will it take, then you have to give 5 years. If the problem was how many months will it take, this is enough, right? But the so you have to read carefully what the problem is asking for. And you do the same here. It should give you exactly 20. The reason it is it's because, you know, this one was missing, right? And of course, this is, you know, we already know that divided by 4, right? 6 years. Okay, so that that brings us to the closure of the future value of annuities. Okay, that brings us to the closure of future value of annuities. You might wonder, but before I move on, let me I'll let you finish up your complete your Excel work. Everyone has Excel file, this file open, right? Were you able to work on it while I was explaining? Were you able to do this while I was explaining?
I was able to get some of them, but not all of them.
Okay, so let me turn this into a formula view, and that was unnecessarily long. I think this is enough. Okay, I guess I'll need to make it smaller, okay, to give you the full. Still, that's not. Okay, I guess that will do, right? All right, so I'll leave this on for, like, you know, for a few minutes. And although I can show you how to do this, all of these using Excel's built-in function, But then I don't want you to do that, except for the rate function, because that's the only thing that you cannot do without you cannot do otherwise, right? Because there's no mathematical single unique mathematical solution or formula for that. The reason is, it's like a black box. In other words, using Excel's built-in function is like just punching in the data, right? And so if you get hooked on using Excel's built-in function, you are turning into nothing but data entry personnel, right? And the data entry personnel, they just enter the data as they see, mindlessly, without thinking what's going on and what is what this is being what this is what is the mechanism behind it, or anything like that. What this is for, what this is being used for, what's the mechanism behind it. Data entry personnel have no mind, no thinking. They just do the tedious job that's given to them. That's a robot, right? And I don't want you to become a robot, right? Data puncher is nothing but, you're just punching in the data. And think about it, Excel's built-in function is a black box into which you just punch in the data. Okay? So if something goes wrong with it, there's no way you can fix. There's no way you can fix it, because you can't open it, and you don't, even if you can open it, even if you open it, you don't know the mechanism. You don't understand the mechanism, right? So I want you to use the formula, right? Of course, you know what the black box is. I mean, black box is, actually, orange box, bright orange box. And black box is actually, flight data recorder, right? Flight data recorder, which is, basically recording, actually, it's cockpit voice recorder, and you must have heard about black box a lot when there is a plane crash. When there's a plane crash, they are looking for the black box, because the black box contains the recording of the conversations, going on in the cockpit. And it's a very hard. It's actually bright orange, because think about it. They're looking for the black box in the crash site, and if the plane crashed from 10,000 feet above, right? If the plane crashed, everything would disintegrate. And if this recorder, it's basically they call it flight data recorder, but it's actually voice recorder, cockpit voice recorder. If it is not in a very hard case, then it will be completely disintegrated. So there's no point. So it's in a very hard metal case that can survive the crash, and it should be easily recovered. So it's bright orange. But the reason it's called black box is hard to open, right? Of course, as I said, it's a very hard metal case. And then you don't know what's, the reason they call it black box is basically, you don't know what's inside. Well, they know what's inside. They know what's inside. But the thing is, it's hard to open. It's very difficult to open. So that's why, black box. But as a metaphor, it means a mystery machine, right? A mystery machine. It's a machine that's full of mystery. You can't open it. You can, figure it out. You can figure out what's the mechanism in it. So think about it. If you are hooked on using the Excel's built-in function, it's a black box. Something goes wrong, you can't fix it because you don't know what's going on, and you are just a data. If you've been just using the Excel's built-in function, or just a calculator, you are a data puncher. If you just use the, because you don't understand the mechanism. And what's important is that understanding of the mechanism or the mastery of the mechanism. So that's saying, you got to use the formula, right? And I've been teaching you how these formulas are connected and how to derive one from another, from the base formula, one from another. That's to all, give you the understanding of the ability to construct, build a mechanism and understand the mechanism, right? That ability to engineer something, right? All righty, so you guys are all done with this? How many people need more time?
I was able to finish.
Okay, you were able to finish that, right? How about the other people? Does anyone need more time?
No, I'm good.
Okay, good. Only two people. What about the others? What about the other people? What's in the oh, okay, that must be from Anna, right? Okay, good, Jalen. All righty. All righty. So we're gonna then move on to the next. The next one is future present value of annuity, and the present value. Okay, so we've talked about the we won't have enough time to cover a lot of it, but just the opposite concept. Remember, in case of future value of annuity, what is the future value of all of those annuities, right? So our end point is this, right? This is our end point, right? End of our timeline. Whereas the present value of annuities are literally present value. So our end point is here, time zero. And all the, that's actually, annuity due. It's normally like this. Normally, these annuities, you're receiving $5,000 every month for the next 5 years at the end of each year. So at the end of every period, there's an ordinary annuity, right? If that's, what's the present value of all of that? So this time zero, we want to know at time zero, that's the present value. And this is annuity due because the payments are made at the beginning, right? So as an example, this is a very rare example. Not rare example, but the rare occasion. Suppose you won $10 million in lottery, right? And usually, in lottery, when you win the jackpot, you have two payout options, right? One is, lump sum. The other one is annuity. If you choose lump sum, they pay you out about 60% of the jackpot amount. Why? Because you will be taxed at the top tax rate, and the top tax rate is 39%. It's almost 40%. And why top tax rate? Because this is a windfall gain. In other words, this is not your hard-earned income. So it cannot, if it is earned income, you go through all, for earned incomes, it goes through all, tax brackets. But, this is windfall gain, not earned income. So you are taxed at the top tax rate. So that's why you get about 6 million. And then if you choose annuities, you will receive annuities for 29 years. It's 29. that's actually what it is. But let's assume 29 is like 30 years. So to simplify, we'll just assume 30 years, right? You receive annuities for 30 years, and monthly, and so monthly. Let's say you get about $20,000 monthly, right? So then 30 years is like 360 months. So in your mind, you just calculate, it's 20K times 360. That's already $7.2 million, right? So you might say, hooray, I'll go for the annuity. No, not necessarily. That's not the right thing. Why? First of all, of course, 20,000, mathematically, just 20,000 times 360 months, and you get, 7.2 million. But this is not the right way of thinking. Why? First of all, the 7.2 million doesn't exist anywhere in a single lump sum. You understand? It's just the arithmetic sum of all those 20Ks, but it doesn't exist today. It doesn't exist 30 years from now. It doesn't exist at a single point in time, right? So that's not the way you can compare it with 6 million. Another thing is, it depends on what is the interest rate. In other words, because all these annuities are basically future cash flows, right? The only way you can compare it with 6 million is by finding the present value of all these annuities, right? You understand? Because 6 million is already today's 6 million. If you choose lump sum, you receive 6 million today, so it's already present value. So then all these, we can compare present value with present value, and we can find the present value of all these annuities. So then we can compare. So if we need to find the present value of all these annuities, then what matters the most is what is the interest rate. Think about it. If the interest rate is high interest rate will discount a lot, will discount cash flows a lot, right? Future cash flows get discounted a lot with high discount rate, but will be discounted little with a small interest rate. So if currently the interest rate is high, then most likely you'll end up with smaller present values of all those annuities than lump sum today. And if the interest rate is very low, like these days, it may be the other way around. It will be the other way around. The present value of all those annuities might be greater than single lump sum cash payout today. Okay, so we'll look into this example next time. Okay, again, all right. So tomorrow, right? The midterm starts tomorrow, right? So please, about the present value part, right? Please study the my YouTube, videos from my YouTube channel. Okay. Any questions? Any questions? Any questions? If there are no, okay, Sarav, okay. I'll take your question after dismissing the class. Alrighty, so if you have questions, just stick around. I will see you guys next Tuesday and stop recording. All right. Have a great afternoon, everyone. Stop recording.
Have a good one.